I'm going to go back to question 3. If you recall, I didn't get the correct answer here, and I used the solution that I had already prepared beforehand. I just want to say something about this. There's one part of this that needs a little bit of explanation. It's not a big deal, but if you look at this equation here, this was the question where you had a two-digit number, two two-digit numbers, and one of them is twice the other. And we finally came to this equation here, 9a equals 20 plus d. Now, you got two unknowns, so how do you solve for this? The important thing is that a and d are digits. In other words, they are numbers that run from 0 to 9. They are digits. So if you read this thing, it means you got a multiple of 9 here, which is equal to 20 plus a digit. So the only multiple of 9, which is 20 plus a digit, is 20 plus 7, 27. Right? None of the others, 21, 22, none of them is a multiple of 9. So therefore, you can conclude that d is 7. And once you conclude d is 7, you already know that c is equal to 1. So your number y will be 1, 7, you see? So it's 17. And x is twice that number, so x will have to be 34. So those are the only solutions. And you got x plus y is the question. You got 17 plus 34 is 51. All right, so I just wanted to explain that. Okay, so if we go down to the next question, which are under discussion. Why is this jumping? Sorry about this. Let's just go to this. Yeah, I think we are going to question 10 now. Okay. So this question says, you've got a, I can say what it is. There's a right angle triangle. The right angle is at the top, as you can see. And there's a right angle. And you got that this line BC is parallel to AD. It's given. Yeah, it's a trapezium. ABCD is a trapezium, so therefore BC is parallel. Right? And then you got the midpoints of the four sides. You got the midpoint of BC is E, the midpoint of AD is F. Then the diagonals of this trapezium, right? You got the midpoints chosen there, and G is the midpoint of this diagonal, and H is the midpoint of BD. So you got four midpoints, right? And then some of these are joined, and the question is, what is the area of this quadrilateral that is formed by joining the four midpoints? So you need to find the area. It's given that AB is equal to 2 and CD is equal to 6. So you know that this is equal to 2 and this is equal to 6. All right. So how do you find the area of the shaded region? Okay, let's just have a look at the isolated diagram. And you see that all right, so how do you find the area? Now, You will have to recall the midpoint theorem, which says that when you got a triangle, any triangle, and if you take the midpoint of two sides, the triangle, suppose the midpoint is here, and join it to the midpoint of the other side, and this is the middle of this line, this is the middle of this line. Let me just indicate it, saying these are equal, and these are also equal. So the line joining the midpoints of two sides of a triangle, right, you can make a conclusion about this line. The one conclusion is that it's parallel to the third side. And the second conclusion is that the length of this is half the length of that. So if this is 3, this is 6. Or otherwise, if this is 6, that is 3. Right, so there are two conclusions about the midpoint theorem. One is that it's parallel to the third side. And it's also equal to 1/2 the third side. So if you look at the four sides of this quadrilateral, let's start with EH. You'll notice that E and H are midpoints of two sides of this triangle here, BCD. E is the midpoint of BC, and H is the midpoint of BD. So from the midpoint theorem, this is parallel to this, and its length is equal to twice the length of EH. Its length is equal to twice the length of EH. Now, if you look at this triangle here, ACD, you'll notice G is the midpoint of AC and F is the midpoint of AD. So therefore, again, from the same theorem, GF is parallel to the same side. GF is parallel to this, and it's equal to twice GF. So this length here, this is the third side, it's equal to twice GF. So it's twice GF if you look at this triangle. But if you look at this triangle here, the same side is equal to twice EH. So from here, you can conclude that EH is actually equal to GF. So you got this line here is equal to this, but it's also parallel because both these lines are parallel to this line here. So it means that they must be parallel to each other. So you got a quadrilateral where the opposite sides are equal and parallel. Now, there is a theorem in geometry which says that if you got any quadrilateral where the opposite sides are equal and parallel, then that quadrilateral is forced to be a parallelogram. Right? You can go and check the theorems on parallelograms, and you will find one of the theorems says that if two opposite sides of quadrilateral, any quadrilateral, if they happen to be equal and parallel to each other, then the whole quadrilateral is forced to be a parallelogram. So this quadrilateral here, you get EH and GF, this is a parallelogram. Now there's one other thing here. You see, this angle is 90 degrees, right? Now this angle here, these two, GE is parallel to that one, EH is parallel to that one, and the angle between these two lines is 90 degrees. Therefore, the lines between these two parallel lines will also be 90 degrees. Right? This is parallel to that, it goes the same direction. This is parallel to that, it's got the same direction as this. So therefore, the angle between them will be equal to the angle between these two lines, which is 90 degrees. So you got a parallelogram where one of the angles is 90 degrees. So what kind of a picture is that? That must be a rectangle. Not necessarily a square, but it's a rectangle. Now, we are also given that AB was 2 and the other one is 6, if I recall. This is 2, and this is 6. Which means that EG is 1, because this is equal to half, 1/2 of that. And similarly, EH, this whole thing is 6 here. So EH will be 3. So EH is half of this, which is 3. So you got the two sides of this rectangle, adjacent sides. One of them is 1, and the other is 3. So the area of a rectangle, so the thing boils down to the area of a rectangle. And we learn at a very early stage that the area of a rectangle is length times breadth. So it's EHFG. So it's one of them is 3. 3 is the length times the breadth, which is 3. Square units. I'm not too sure whether they gave you the units. Always must write down the units. Let's see what they say here. 2 centimeters. You will see right at the bottom, you got these things are 2 centimeters. So the area is 3 square centimeters. Because the original lengths were given in centimeters. Okay, so this is the solution to question 10. Clear the drawings. And I'll just look at the solution which I worked out, and that is true. Right at the bottom, you see that the area is 3 square centimeters. Okay, so let's just get on to the next problem. Question 11. So question 11 says the following. In the year N, the 300th day of that year was a Tuesday. Okay, we're not given what year it was, 1957 or 2023. We don't know what it is, but it doesn't really matter. The year N, the 300th day of that year, just draw a timeline here. So you got the year N, this is day 1, the 300th day, this is, it happens to be a Tuesday. I'll put TU, it's Tuesday. And then that year ends. We don't know where it ends in. Oh, this is the year N. We also speak about year N minus 1. So let's just be a little bit careful here. We'll separate these here. You got the year N, N plus 1, and N minus 1. So let's just imagine that this is year N minus 1. And this is year N, the year N plus 1. They mentioned these 3 years, 3 consecutive years, N minus 1. And the question is, in what day of the week did the 100th day, you got 365 or 366 days here, but the 100th day, question is, what day of the week is it? Now what's given? It's given that the year N here, the 300th day was a Tuesday. But that's quite close to the end of the year. So this is a 300th day. That happens to be a Tuesday. They also say that in the year N plus 1, the 200th day was also a Tuesday. So the 200th day was also a Tuesday. Okay, so you got both these, but you don't know what that is. All right, now I just want to see how far is this from that. Well, you've got 65 days to the end of the year. Or it could be a leap year. It could be 66. So you got 65 or 66 days up to 365. It's 365 or 366, we don't know. But whatever the case may be, from year to year, from year day 1 to 200, there are 200 days here. Right? So the number of days between this Tuesday and that Tuesday is either the number of days between two consecutive Tuesdays is it's either 265 or 266. But if you've got consecutive Tuesdays, all Tuesdays are 7 days apart from each other. From one Tuesday to the other, it's 7 days. You keep adding Tuesdays. So the difference between any two Tuesdays is a multiple of 7. This should be a multiple of 7. And then you will see the 266 is actually 7 times 38. So therefore, it's 266, not 265. So what does this mean now? It means up to 365 or 366, depending on whether it's leap year. So happens to be 366 days. So this is a leap year. N is a leap year. Because it's got this N, it will have 366 days. All right, so it means the years adjoining it, they are not leap years, because leap years only occur once every 4 years. So this has 365 days, and this also has got 365 days. Okay, now let's go back here. If this is a Tuesday, we need to know about this. And we do know that this has got 365 days. So if you go up to the end of the year, it's 365. And there's 65 days there. Right? And then we're talking about year n minus 1. And then from here to here, you got another 300 days. No, it's not 65, it's 265, sorry. From 100 to 365, there are 265 days left for this year. And then this is the 300th day from one of that year, the nth year. So the distance between these two let me get this thing out here. The distance between these two, between this and that, is 565 days. And you know that this is a Tuesday. You have 565 days. Now, how many sevens are there in 565? 565 divided by 7, you get 80 remainder 5. which means that if I add 2 to this, it'll be a multiple of 7. Remainder 5, you see. So if you add 2 to this, it'll be remainder 7. So it's 87 plus 1. So 567 is 7 times 81, you can see that. So that's a multiple of 7. So 567 days from here backwards is a Tuesday. From here to here is 565. So here, another 2 days here, 567. And this is a Tuesday here. It has to be 2 because 565 plus 2. So 2 days before the unknown date is a Tuesday, right? So therefore, the 100th day of the year n minus 1 the year n minus 1 is 2 days before that is a Tuesday. Then the next day will be Wednesday, is a Thursday. This problem is quite a tricky problem, but it doesn't require too much. You just not need to know how many days there are in a year. Just be careful. The number of days in a year is either 365 or 366. And the information that is given allows you to conclude that there's a leap year in between, because 266, you have to arises out of a year which has got 366 days. So therefore, the middle year, the nth year, is a leap year. And you can say the other 2 years have got 365 days between. That is why I can say from here to the end of the year is 365, no doubt about that. And there's 265 days up to the end of that year. So I can make that calculation. Okay, so the answer is a Thursday. Here it is. You can see at the end of this, there's some argument. It looks as if it's got another argument to mine that I gave here. You can read that if you want to. All right, we go on to question 12. Question 12 says that n is a 5-digit number. Earlier on, I told you that a 5-digit number, we can put it as A, B, C, D, E. We don't know what the digits are, but I put it like this, 5-digit number, to distinguish it from a product. Okay. Q and R are the quotient and remainder if n is divided by 100. Now, when you divide a 5-digit number by 100, if you take, for instance, 56521, if you divide it by 100, you'll get 5. This is 56500 plus 21, right? So if you divide this by 100, you're going to get a quotient of 565 and a remainder of 21. So this first 3 digits is a quotient when you divide this entire 5-digit number by 100. So they say the quotient is Q. So that is Q, the 3-digit number. And this R, this has to be the remainder because it's a 2-digit number. So it's small. It has to be smaller than 100. And any number smaller than 100 is a 2-digit number. Okay, so you know exactly what Q is and what R is. All right, now the question is, for how many values of n is the sum Q plus R divisible by n? So in other words, you want n to be divisible by 11 at least. You want Q 11 to be a factor. I use this vertical symbol to be a factor, like 7 is a factor of 21, or 33 is a factor of 66, and so on. It's a short shorthand for a factor. So 11 is a factor of q plus r. Now, this number n is actually equal to, this is n. N is a 5-digit number. But this is also equal to, as we saw here, this is your n, it's 100q plus r. This is your q. There's 100 of these plus this 2-digit number. I want 11 to be a factor of q plus r. Now, the n is, how do you get that from that? Well, you have to add 99q. So let me add 99q. Instead of writing 9, I'm start writing a q, which looks very similar. Let's take that out, and I want 100q. So I want 99q plus q plus r. That is your 100q plus r. This is equal to your n. Now, if 11 is a factor of this, and you're adding 99q, this is also my multiple of 11. It means that 11 is a factor of this also, because you're adding to a multiple of 11. This is a multiple of 11. You're adding another multiple of 11. So 11 will be a factor of n. So we want to know, for how many values of n is 11 a factor of n? See? This works both ways. If 11 is a factor of this, then when I subtract a multiple of 99 like this, I will have, so it works, that arrow can go both ways. Okay, but this is your ln. So 11 divides n. So we want to know for how many values of n is this true? And what is n? N is a 5-digit number. So the question is really, this is n. So the question, it can be translated as follows. Question: how many five-digit numbers are divisible by 11? All right, now, so that is a question now, because this is a random 5-digit number, but all you want to know is whether 11 goes into it. So let's see, the 5-digit number that starts from 10,000. 10,000 is the first 5-digit number. Now, what is the closest multiple of 11 to 10,000? I want to know the smallest possible 5-digit number. Okay. So how do I answer that question? What is the smallest possible 5-digit number? Well, let's see. When I divide 10,000 by 11, I'd like to know what the remainder is. Eleven goes into this 9 times. 99, 100 goes to 11, 10, 0 times 100, 9. The remainder is 1. So in other words, 1001, 10,000, when I add 1 to it, no, it leaves the remainder of 1 when you're dividing by 11. You have to add 10 to it to make it a multiple of 11. That's the smallest number you must add to this to make it a multiple of 11. The remainder is 1, is 10,000 plus 10. So you have 10,000 plus 10 is 10,010. So the smallest so whatever you're saying, the smallest 5-digit number that is a multiple of 11 is 10,000 plus 10. So that's 10,010. You can check the divisibility by 11. 1 plus 0 is 1, and 0 plus 1 is 1. So this is a multiple of 11, and it's the closest multiple to 10,000. So the multiples of 11, the first one is 10,010. Now I'd like to know what the last one is. So the next one will be 10,000. Now you have to add 11, 21, and then 10,000. Add 11 to that, and so on, until I come to the very last one. Now, what is the last one? It goes up to the largest 5-digit number is the one with 5 nines in it. So let's go to the largest 5-digit number. The largest 5-digit number is 99999. Okay. Now I can see what the largest one just before this. You see, it has to be 9999. You can see clearly that this is 11 goes into this 909 times. So that one, it's only 9 units away from there. So this is a multiple of 11, and it has to be the largest because it's only 10 away or 9 from the largest 5-digit number. If you don't like that, you can divide this by 11 as we did the last time, and you will see you get remainder 9. Remainder 9. So if you subtract 9 from this number, you're going to get a multiple of 11 because it's 9 more than a multiple of 11. So when you subtract 9 from this number, this is what you will get. I can't add 2 to this because you move into a 6-digit number. See, so I want to still remain at the 5-digit number. So this thing goes all the way up to 99990. So these are the multiples of 11. So I'm going to write this down here. The 5-digit multiples of 11 are the 5-digit multiples of 11 are, starting from 10,010, then 10,000, add 11 to this, and so on. It goes all the way up to 10, what is it? 99,990. So you want to know how many there are? We don't know. So what is the number? How many terms are in the sequence? It's a sequence. And you can see this is an arithmetic sequence. Because you're adding the same number all the time, namely 11, to get to the next one. And we know a couple of things about this. The first term, A, is 10,010. We want to know how many terms there are in the sequence. So we know the nth term is 99990. All right. So this is a formula involving the nth term of a sequence. So in arithmetic sequence, you have that the nth term is the first term plus n minus 1 d. The problem is to find n, the number of multiples of 11. So we know that the last one is that one there. That's the nth term. It's 99990. That's your Tn. And A is 10,010. That's your A plus n minus 1 times D. D is 11. Okay, so you got an equation here with only one unknown. So that is the equation that we will have to solve. What is n? See, so this problem here is actually an interesting problem for giving you the application of the arithmetic sequences, but it's disguised in such a way, very cleverly disguised, so that you don't see it. So really what happens is that I need to solve for n here. So you have n minus 11 into n minus 1. I'm looking at this one here, is equal to 99990 minus 10010 minus that. If you take it to the other side, and you have 0, and you get 8, 9, 9, 8. So 11 into 9, n minus 1 is this number. So n minus 1 is this number, 89980 divided by 11. And you can quickly check this to see that's 8180. That's n minus 1. And therefore n is equal to 8181. And these represent the multiples of 11, which are the 5-digit multiples of 11. Answering the question is the number of multiples of 11. Multiples of, number of multiples of 11, 5-digit. And we saw the 5-digit numbers are precisely those where Q plus R is divisible by 11. All right, I'm sorry, I've got all over the space here because I didn't have enough space to, I should have left some space to write this thing neatly. So I've been traveling all over the page. But the answer is finally 8181. Okay, so if that was written untidily, the model answer that I got, usually written quite neatly, and you will see that I've got 8181 there. But I think I did it slightly differently. You can see I've got some other numbers here. Well, this is a more advanced solution. But the solution that I gave you is more direct, and it answers the question clearly. Okay, so the next question that we need to tackle is question 13. There are 15 problems in the team competitions. The individual, we are looking at the individual, where people answer these questions alone. That's what they call them, individual. But there is in the team competitions, you also have, they are part of a team of 10. And they all together put their brains together to solve the problems in some way or the other. So here, these guys are unassisted in this thing. So in the diagram below, there are 15 problems. Here we are almost to the end. Arcs AC and BC have centers B and A. So you can see this is an arc. This is an arc here. The center of this arc is this. It's an arc. So AB is the radius of this arc. Let's call this radius capital R, because I've got another small radius here, which you can call small r. Small radius and a big radius. Okay, so the radius of this arc is that, and the radius of this, they say the center of this arc is B. So this R is also the radius of this arc here. So these two arcs have the same radius. So what I can do is the following. So if I join A to C and C to B, what I have is this radius here is the same as that. So this is an arc, you see. And this is the center. So AB is the radius. So AC is also R. So AB, we put it here, AB is equal to AC is R. You can see AC is the radius as well. And here you've got BA is the radius for this arc here. And BC is also the radius for this other arc. So it's also equal to BC. So in other words, these three sides are all equal. So you have an equilateral triangle. ABC is an equilateral triangle. The circle is tangent to these arcs. This circle is tangent to that, and it's also tangent to that. It just touches it. Okay, so that's the other information that is given. They also give you the length of the arc, BC. So this, the arc, length of the arc, BC, not a straight line, is 12 centimeters. So the length of the arc BC is 12. Now, that arc at the center, the angle is 60, because this is an equilateral triangle. So what I've got here is, I just want to summarize what you've got. I've got a large circle. Let's try it here. Okay, this arc here has got radius R. I'm going to just draw that. The capital R is here. And the BC, oh, wait a minute. We're looking at BC. Let's just draw it from this side. So the arc BC, from here to here, it's 12. Oh, sorry. From here to here, this arc here is length is 12. But we saw that when you join it to the center, this is 60 degrees. because this is an equilateral triangle. So you've got the 60 degrees, you got 2 here. So you can work out the circumference of the circle, because if you draw another 60 degrees, you get 120 and 180. So all these will be 2, see? Because they're all exactly, they're arcs which have got 60 at the center, so they're identical arcs. So there are 6 60s and 360, and therefore the circumference of the circle is 6 2s, because you add 2 and 2 and 2, another 3 2s at the bottom. So the circumference of the large circle is 12, 6 times 2. Right, I'm going to go to the next. Oh, actually, I shouldn't have taken everything out, but the final conclusion was, this is R, that's the radius of the large circle. We've got that 2 pi, the circumference of that will be 2 pi times the radius, and we saw it's equal to 6 times 2, which is 12. So pi r is equal to 6. Okay, we'll just hold on with that. That allows you to calculate the large radius, you see. But the question here is, what is the circumference of the circle? In other words, what is the circumference of the small circle? Now that circumference will be, the radius is r here. So we need to work out what is 2 pi small r. Now to do that, you need to work out small r. The only thing we have is capital R. Okay, now there is something that we need to know regarding circles which are tangent to other circles, or even to lines. And that is the following. If I have a large circle, and then I have another little circle which is tangent to it, let's draw another little circle here. Right. And we want the circle to be touching this circle. I'm going to push this thing so that it touches it. Oh, that's cute. This is the first time I've ever drawn this kind of a picture. I've been happy that it's somewhat successful. Let me make it touch nicely. Right, there we go. Now, the interesting thing about this is that there are 3 points which are in this figure here. The 3 important points. The 3 points are the center of this large circle, the center of the large circle, the center of the small circle, and the point of contact. Right? The point of contact, it turns out that all these 3 are in the same straight line. Normally, you don't have 3 points in the same straight line. 2 points, yes, but not 3. So they are collinear. So you can see they all lie in the same straight line. The way to prove that is you just draw the tangent here. Right? Then you will know that when you join the center of this circle, it's a common tangent. It's a tangent to the small circle as well as the large circle. So this radius and this radius are both perpendicular to this tangent at this point. So they must be on the same straight line. And you can see. Okay, so in this picture here, you have the same story, but it's sort of disguised. You see, there's the center of the large circle, there's the center of the small circle, and there's this point of contact, which means that when I join this point here, see, you can see it's going through the center. These 3 points lie on the same straight line. And the same thing with this. If I join this, all right, so you got this is small r. Now we can see something interesting, because the large, I'm trying to calculate the small r. This entire thing here is a radius of the large circle. So the entire thing, this is the center, you see, and you're going up to the boundary. So this whole thing is capital R. So this small piece here on this side is capital R minus small r. And likewise, this is capital R, and this is capital R minus small r. So what do you have? You've got this line here is perpendicular to this. So what you've got here now is the following. In this picture, I just want to isolate a triangle, the small triangle here, where all the sides are known. You've got this picture here. I want to look at this triangle here. Let's do it like that. This one side is capital R minus R. And so here is also R minus R. And you got a perpendicular line. Now this is a very familiar picture. One of my favorite pictures. Namely, you got an isosceles triangle. And you got a perpendicular to the other side. It's not very isosceles, but anyway. These two are supposed to be equal. Right? And whenever you got that situation, then these two triangles become congruent. It's a very, very important result in isosceles triangles. Whenever you got an isosceles triangle, I tell in all my talks, whenever this situation arises, I tell them when you got an isosceles triangle, one of the first things you must do, or that you can use, which is very powerful, even in your school mathematics, is that you can divide an isosceles triangle into two exactly the same triangles, right? You can divide it into two congruent triangles by in any one of 3 ways. You can either take this as the midpoint of this and join it, then the two triangles will be congruent, or you can bisect this angle, the top angle, the two triangles will be congruent, or you can draw a perpendicular to the other side, as in this case, the two triangles are congruent. So here you can see very quickly the two triangles are congruent because you got hypotenuse, right angle on the side. So the important thing here is that this thing here is R over 2. This length is R, and this is capital R over 2. So in this right angle triangle, you got 3 sides. The sides being capital R minus R, small r, and capital R over 2. So Pythagoras kicks in. And I would like to use a difference of 2 squares so I can simplify. I can say this squared is equal to this squared plus this squared, but I can also say I need to work out small r. So small r squared is capital R squared r minus r, that's your hypotenuse, minus r over 2 squared. Oh, wait a minute, I don't like that. Let's make it capital R squared. That's not going to simplify anything. I'm just looking for a shortcut. So you get small r squared is capital R squared minus, no, I'm sorry, I'm doing the same thing all over again. Sorry, I wanted r over 2 all squared on the side. I wanted this r over 2 all squared is equal to capital R squared minus small r squared. Now this is the difference of two squares, you see. So you have, this is r minus r into r minus r plus r. And the nice thing about it is this just, the small r's cancel. You have r into r minus 2r. This is your r minus 2r. And here you got r squared over 4. So you can cancel one of the r's there, and you get 2r can be made into the subject. We're looking for small 2r. 2r is capital R, this minus r over 4. That's r minus 3, a quarter of it, which is 3/4 of r. And we are looking for 2 pi r. So all you have to do is to multiply this by pi. Multiply both sides by pi, and you have 3 pi r over 4. And we saw that pi r is 6, you see. So this is 3 times. This is r squared over 4. This is not the correct answer. So you have the r's cancel. You got 2r is equal to 3/4. So when you multiply on both sides by pi, you get this, and pi r is 6. So this gives you 18 over 4. Four comma 5. I don't remember. I worked this thing out. All right, so what happened here is the circumference of the large circle is obviously this, but this is correct. Pi r is 6. Now I've also got that in this diagram here, this is r minus r, this is r, and this entire thing is obviously r again. So you have capital R over 2 in this, and therefore you can use Pythagoras to say that this thing here squared, which is r over 2 all squared, is hypotenuse squared minus this. So you have this minus this, which is r minus 2r, into that plus that, which is r. So you got r minus 2r cancels off with r squared over r over 4. And so you have 2r is equal to 3r over 4. And the circumference of the circle is 2 pi r. So all I have to do is to multiply this by pi on both sides, which I have done. And as know that pi r is 6. And I can't find any errors in this. But let's just go and see what my answer is, because I don't remember 4,5 to be quite honest. Somewhere along the line I made a mistake. Yeah, unfortunately, See, my answer is 27. So let's just see what happened. So what we've got here is, in the end, you got circumference is 2 pi r, 2 pi times 3r over 4. A is the radius of the circle. That's what, oh, the radius is 2a. So we had, sorry, we had that it's 72. Oh, it's 12 centimeters. It wasn't 2. The original, I thought that was 2 centimeters, but it's really 12. I think that's where we went off. Sorry. Oh, the length of the arc is 12. Sorry, not 2. I was working with 2 all the time. So the answer is really 6 times whatever I've got. Because, and I got 4.5, and 6 times 4.5 is 27, which is the correct answer. Sorry, I didn't read my question correctly. See, which is bad. So BC is 12, not 2. So the circumference is 12 times 6, which is 72. Okay, so the answer is 27, which is 6 times 4.5, which is what I had. Okay, let's get on to the next question, question 14. Question 14, it reads the following. A strictly increasing non-negative integer valued function fn satisfies this. You got a funny looking equation here. You've got f of n plus f of m equals fn plus m plus 1. This is what you call uh, there's a name given to these types of equations. Uh, Functional equations. I think they call them functional equations because equations are defined in terms of functions. So you got an integer valued function, which means that for each n0 from 0 to onwards, for 0 and 1 and 2 and 3 and so on, you got a function f. It sends 0 into something, 1 into something, and so on, right? So this is really f of 0, f of 1, f of 2, and so on. And the question is, what is f of 2023 there, given that f satisfies this funny thing here, right? And it's also strictly increasing. Strictly increasing means that the graph of this keeps going up. It doesn't get flat anywhere. So it never flattens. So if you got a value here and you got another value here, this value, this value on this side is bigger. This value here is strictly bigger than this. So this f0 is less than f of 1, is less than f of 2, because it's strictly increasing. That's what you mean by increasing function. The values, as your domain values increase, then these values also increase. So this is what you've got, is given. So you're asked to calculate F 2023. Now, as a starting point, you've got this funny looking equation here. Let's put both n and m to be both zero. It's your starting point. So if you take this and make n and m to be zero, let's just substitute f of n equals zero, m equals zero. So you got f of zero, putting m to be zero, and the f of all that, double bracket, and this is f of 0 plus 0 plus 1. I'm putting both n and m to be 0. Now, you notice f of 0 occurs twice here. So let's give a name to f of 0. Let's call this a. Right? F of 0, we'll call it a. So what is the meaning of this? 0 plus a. And this is a plus 0 plus 1, which is a plus 1. And 0 plus a is f of a. Now that is very much more manageable. F of a is a plus 1. So wherever a is, we know where it is, but the value for f of a is one more. It's a plus 1. Right? We don't know of the others. Okay. So this is a useful equation. Now, what I want to do here is you see, I know f of a. So why don't I put a here in this? And put a in both places. No. Put a here and put 0 there. So make n equal to 0. And m equals a. So what do you have? Same equation. It'll be f of 0 plus f of a is equal to, and here n is 0, so f of 0 and m is a, plus 1. Okay, this tells you that this is f of a is a plus 1, and f of 0 is a, so you'll have a plus 1. That gives you 2a plus 1. Okay, it turns out that you can't really do much with this one. I tried it out and I can't really do much. So I must make some other reasonable substitutions. It turns out that the substitution you must make is not f of a plus 1, but f of 2a. So we have this important equation here, namely f of a equals a plus 1. And I want to work out f of 2a. Now why is that? I've got 2a is a plus a, you see. And a is f of 0. We said f of 0 is a. I'm going to put a, and this f, a there, second a, I'm going to make it f of 0. Right. Now, you've got f of why did this thing go up, Oh, there it is. So you know that f of n plus f of m equals, it's very easy, unwieldy equation. Now I've got a plus f of 0, see? And I got f of that. All right. So a is equal to n and m is equal to 0. So this becomes a and m is 0. And that's a formula. It says that if n plus, the image of n plus f of m is f of n plus m. So here, if you put n equal to a, which I've done, and m equal to 0, then I get f of a plus 1. But remember, f of a plus 1, f of a is a plus 1 plus 0 plus 1, which is a plus 2. So f of 2a, which is equal to this, is really a plus 2. Now you have f of a is a plus 1, and f of 2a is a plus 2. And I'm trying to calculate f of 2023, so I'm looking for some kind of, trying to search for a proper formula for f of n. Right? Now, let's just concentrate on this a here. Is it possible that a equals 0? Is a, in other words, is it possible that f of 0 is equal to 0? Well, if that is the case, then from this equation you've got, if a equals 0 in this equation here, then you got f of 0 is 0 plus 1, which is 1. And but f of 0 is a, and we are saying that a is equal to 0, so you got 0 equals 1. This is impossible. If a equals 0, you got 0 equals 1. So a is not 0. It actually turns out that a is 1. A is actually 1. I'm going to prove this, but that is not intuitive. I'm trying 0, and I'm going to try 1. But to prove that a is equal to 1, I'm going to assume that a is not 1. So suppose a is not equal to 0. We just proved it. And suppose a is greater than 1. I want to come to a contradiction. If a is greater than 1, I want to prove that this is impossible, in which case a will be forced to be equal to 1. You see? It's not greater than 1, it's not 0, so it has to be 1. Right? Now, suppose a is greater than 1. Now, this is what we've got here. You see, we've got a and 2a. A is here somewhere, and you got 2a somewhere. And if a is greater than 1, like a equals 2, this will be 2 and this will be 4. And if a is 10, 10 and 20. But the point is, there is always an integer in between a and 2a. See, if a equals 1, it doesn't work. a equals 1, and this will be 2. There's no integer between 1 and 2. But as long as a is greater than 1, there's always another integer strictly between these two. Right? If a is 2, k will be 3, because that's in between. And as you make a larger, there'll be lots of k's. So you have an integer like this, which is strictly between these two. Now what I said here is that then it means that f of a is less than f of k is less than f of 2a. Because this is a strictly increasing function. It says so, right? So it's strictly increasing. Now, what did we have? We had that f of a was actually equal to a plus 1, strictly less than f of k, and f of 2a is a plus 2. What is this saying? It says that this is an integer valued function. In other words, f of k is an integer. The values of f are integers. To say it's integer valued function. So k is an integer, and f of k, so this is an integer. Now you've got an integer that lies strictly between two consecutive integers. Look at it. These two are consecutive integers. You're adding 1 to this. It's impossible. You can't have an integer which lies strictly between two consecutive integers. So you get a contradiction here. A contradiction means you achieve something which is impossible. And the reason for that was that I assumed that a is greater than 1. As long as I got a greater than 1, I get a contradiction. So that allows you to conclude that a is not greater than 1. It's not equal to 0. So therefore, a will have to be equal to 1. A is equal to 1. Okay, so I'm going to remove all these. Now I know that a is equal to 1. So f of 0 now is 1, because we said a is not equal to 1. Right. And f of 1, f of a is a plus 1. So if you put a equal to 0, you'll get 1 plus 1 is 2. Right? In fact, you can put m equal to 0 in this case here. Let's do it like that. So in this case here, you got f of n plus f of m is equal to f of n plus m plus 1. Now, when I put m equal to 0, I got f of 0. But we know that f of 0 is equal to 1. I'm going to put m equal to 0, f of n, m equals 0, 0 plus 1 is 1. Now you got a very interesting equation. You got that f of n plus 1 is equal to, well, I don't really have to do anything like that. Oh, otherwise, yeah, maybe I'm going to do it like that. You got that f of n, if you take it this way, is 1. In other words, the image of n plus 1 is the difference between two consecutive images is 1. So this is 1, this is consecutive, so this has to be 2. And this is the next one will be after 3, be 3. Because the difference between f of 1 and f of 2, this is what we got, is 1. So this is really an arithmetic sequence. You keep adding 1. So f of 2 is 3, and so on. So if you go on like that, you got an arithmetic sequence whose first term is 1, common difference is 1, and you can go to F2002. you can see that each one goes to 2, 2 goes to 3, 3 goes to 4. So this will be 2024. So that's the answer to this question. It's not an easy question because it's functional equations. You have to decide what you're going to substitute and exploit the function. For different values, you've got infinitely many values. They're saying that no matter what n and m are, you've got a formula for that. So you can put anything you like, but you have to choose these n and m's judiciously, with a certain amount of intelligence to make progress to get to your answer for the formula for f of n. So that's what I got here. This is really a formula for f of n. In the end, you got f of n is equal to n plus 1. See? The difference between two consecutive things is one is a arithmetic sequence starting with 1, and therefore it's just a sequence of natural numbers. All right, so bearing that in mind, we can just go to my model answer, and you will see I got the same thing, right? And if you didn't understand what I said, you can read this thing again and come to get a better understanding of it. That is why I wrote down the model answers also. Okay, now question 15. That's the last question. In this, a 3-digit number n and a 2-digit number m are multiplied as shown below. So there it is. M is a 3-digit number and this is a 2-digit number. Now this is not an alphametric. It says here that E and O are even and odd. So this is an odd number. It could be any one of the, it's a digit. It could be 135.7. And this one here could be 0, 2, 4, 6, 8. So these even, all you know is that you got 0, you got odd, even, times even. You got this whole calculation here, and that is equal to odd, EE. Looks like a very difficult problem. But how are we going to find out what these things are? Because there are so many possibilities. But the nice thing is, it is known that the product is one of these. So now remember, this E and E are not equal. They are even. All right, odd. Now it's going to be one of these. So which one? All right. Now there's something that let's start with what we are given. This number here is an even number. Because the last digit is even, right? So is EE, because the last digit is even. So you're multiplying two even numbers, right? The product of two even numbers is what we've got. It actually is a multiple of 4. Because you got 2 times something, times 2 times something, must be 4 times something. So your answer is going to be a multiple of 4. All right, so you have to see of these now, which are multiples of 4. They say the product is one of these. Now, all you have to do is look at the last 2 digits. Now, this is not a multiple of 4, so you can eliminate it. This one here is a multiple of 4 because 44 is 4 times 11. This is also a possibility. And this is not a multiple of 4, 42. You can eliminate it. And this is a multiple of 4. 64 is 4 times 16. So there are 3 possibilities. Now, so they want to know which one. So I can try 9744. Okay, you got the last two are even because you got even, 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 even. That's fine. Even, even. I mean, in every one of those. But it's a multiple of four, so any one of these three will work. Now, I need to find out whether this thing is a product of two numbers like this. 9744, you have to factorize this thing. 9744. I can see 4 goes into this. So you got 2, 4, 3, 6. 4 goes into this also. 609. 3 goes into this. 203. 203 is 7 times goes into this 29. So when you factorize this, you get 4 times 4 times 3 times 7 times 29. Now you want to get a 3-digit number. There are several 3-digit numbers factors. I want to look for a 3-digit factor. The 3-digit factors are okay. 7 times 29 is one of them, and 203 times 3, which is 627, 609. And the other one is a 2-digit number, remember? So if I put 29 times 7, this gives you times 48. Now, if you take 203 times 3, then you got 16 here. And then 203 times 4, 812 times I pressed one of these buttons in error. So, hmm. Uh-oh. I've lost my pen. Just hold on. Oh boy. Sorry about this. Some funny thing is going on here. I don't know how to get out of this. Hmm. Just one moment, please. There are two buttons on this pen, and you're not supposed to press any one of them. And I did so. Okay, this seems to be. Ah, okay, I'm okay. So you got 812, and that is 203 times 4. So the other one is 12. Now there's one other one which is 29 times 12, which is 348. There are others. 29 times 12, and this gives you 28. And the reason why I got this is that, you see, you need an odd, even, even. So you need not even try this, because this is not odd, even, even. This is even, odd, odd. I need not try this too. Need not try this. But I can't try this one here. This is odd, even, even. And here you got even, even. So you got this. And this actually, if you multiply these two, you're going to get 9744. So it turns out that this works, right? And when you multiply it in detail, as you can see here, I've done it. There's 348 times 28, right? You'll see this is what I get. And here you got E-O-E-E, even, odd, even, even. And the same thing, E-O-E, 0. So you got E, even, odd, even, 0. So this is the actual multiplication table that we're looking for. All right. But the other ones, there are still two others, which we said 7328. And then I'll look at my answer here. 7164. This is 9 goes into this. 8 plus 6 is 14, plus 4 is 18. So you can take out 9, and then you can take out 4 as well. Right, it's a multiple of 4. When you work it out, you get this. Now, again, you have, this is not even. You need to get odd, even, even. Now, this is not odd, even. It's all odds here, so you can eliminate that. And even this, these are the only 3 possibilities here. And you don't get, anyway, you don't get odd, even, even. So this thing here does not admit a factorization like that, because you need to have one of the factors to be an odd, even, even. And the same thing with 7328. There are only 2 ways in which you can factorize that, and you don't get odd, even, even. So this one is eliminated. But this is the only one where you have odd, even, even. So that is the answer. So that takes care of problem 15. And that's the last one. Okay. So thanks very much for listening. And that brings us to a close of the individual senior paper that was set in 2023 with 15 questions. Okay, enjoy the rest of the day or enjoy the rest of the evening.